Warnings don't usually arrive as alarms. They arrive as paperwork. In movies, disasters are preceded by obvious signs. Cracks spread dramatically. Alarms sound. Someone shouts that something is wrong. Real life is quieter. In real infrastructure systems, danger is written in technical language, buried inside reports, spreadsheets, and inspection notes. And those warnings rarely look urgent. Years before the collapse, inspections noted issues. Not emergencies, not failures, just observations, components under stress, fatigue indicators, design elements that no longer met modern expectations. Each note was accurate, each concern was documented, and each one, on its own, seemed manageable. Engineers don't think in absolutes. They think in margins. How much load can this component handle? How much redundancy exists? How quickly is degradation progressing? Risk is not binary. It is probabilistic, and probabilistic risk is easy to postpone. Inspection reports used familiar language. Monitor, evaluate, plan for future repair. None of those words imply urgency. None of them suggest immediate danger. And that matters because language shapes decisions. Here is a critical truth. Knowing about a problem does not mean acting on it. In large systems, awareness is only the first step. Action requires budget allocation, scheduling, political approval, public communication, and each step introduces delay. The bridge was not forgotten. It was reviewed regularly, but each review ended the same way. Yes, this needs attention, but not today. Deferred maintenance becomes routine when nothing bad happens. And every day the bridge remained standing reinforced the belief that waiting was acceptable. Closing a major bridge is not a technical decision. It is a social one. Traffic disruption, economic impact, public backlash. Officials understand this. So unless danger is unmistakable, closure feels disproportionate. And danger, in this case, was subtle. Infrastructure systems are designed to avoid panic. They are built to be conservative, slow, and measured. That's usually a strength. But sometimes it becomes a weakness, because slow systems struggle with rare, high-impact risks. To close a bridge, someone must be absolutely certain. Certainty is rare in engineering. Stress does not announce when it will cross a threshold. Components do not send warnings when they are one cycle away from failure. They simply fail. Over time, weight increased. Traffic got heavier. Vehicles got larger. Temporary construction loads added stress. Each change was approved independently. No single change appeared dangerous. But together, they altered the bridge's stress profile. And that change was not visually obvious. Every successful day became evidence. Evidence that concerns were theoretical. Evidence that margins still existed. The bridge did what it had always done. And as long as it did, warnings felt abstract. This is not a story of incompetence. It is a story of human psychology. People underestimate risks that develop slowly, have no precedent, lack visible symptoms. Infrastructure failures are rare, which makes them easier to dismiss. Many disasters are preceded by near misses. This bridge had none. No partial collapse. No visible deformation. No dramatic warning. And without a trigger, systems rarely change course. Modern bridges are designed to survive individual component failures. This bridge was not. If a critical element failed, there was no backup path for the load. That vulnerability was known, in theory, but it had never been tested. The most dangerous assumption was not that the bridge was safe. It was that failure would announce itself, that there would be time to react, time to close lanes, time to intervene. That assumption was wrong. Nothing happened, and nothing happening felt reassuring. Silence was interpreted as stability. But silence can also mean that stress is accumulating quietly. Once a bridge is scheduled for future replacement, urgency fades. The problem will be solved later. That mindset reduces pressure to act now. Future plans create present comfort. This question always follows disaster. But responsibility was distributed. Inspectors documented. Engineers analyzed. Administrators prioritized. Officials approved budgets. No single person ignored the danger, and that diffusion made decisive action unlikely. The bridge was known to be less robust than modern standards. That fact was not hidden, but it was framed as a long-term issue, and long-term issues rarely feel urgent. On the final day, nothing unusual was reported. Traffic flowed. Inspections did not indicate imminent danger. From the outside, it was just another day. That normalcy is what makes the collapse so shocking. Engineering risk lives in percentages. Failure lived in certainty. At one moment, stress exceeded capacity. Not gradually, instantly. There was no transition phase. Every warning was accurate. Every report was honest. What failed was timing. Action arrived too late. Why didn't someone stop this? Because stopping it required certainty, and certainty never arrived. Up to now, this story could describe many bridges, and that is intentional, because the system that allowed this failure still exists across the country. In the next part, we stop speaking in general terms. We name the bridge. We walk through the exact day, minute by minute, because this was not a hypothetical failure. It happened in the United States, during rush hour, with people just like you.